Enoda is actually an energy-based company that delivers solution for like existing energy grid with a couple of devices, including hardware and software, um, which is next generation of transformers or substations, as well as a couple of other devices under development and embedded software. And we are using blockchain and other technologies for coordination of these and other third-party devices for getting some basically optimal solutions for current problems in the grid. And today's talk will be mostly about the Interchain Stack. It is basically the stack of technologies we are using in our team to build the blockchain platform. And it consists of Cosmos SDK, Comet BFT, Cosmos, IBC, all of them I will explain one by one. Before this talk, I wanted to just clarify that if we talk about Ethereum and EVMs, it is a huge infrastructure consisting of billions of dollars, which include like the core protocol, the clients, the explorers, wallets, some other tools, oracles, and all of that, including also a couple of side chains, layer 2s, which brings us to multi-billion infrastructure. And sometimes people even wonder, like, why should I select some other technologies to build something? And there are also a couple of other emerging ecosystems like Solana's or Cosmos-based Interchain Stack or Polkadot, which are also building a lot of like infrastructure and tools so that developers and users can leveraging these technologies can build some products. And yeah, today it will be mostly about the Interchain Stack, which we adopt for our blockchain-based solution in a company. So hope it will be useful. The agenda for today is the following. We'll cover like modern blockchain solutions, like why we came up with this particular stack of technology, rollups, Interchain Stack components. I will also mention about like what we are doing at Enoda right now and present you the Ensemble. The Ensemble is basically the blockchain transactive platform that we are creating at Enoda. And we will have some time for Q&A, hopefully. So yeah, most of you are already familiar with like the major blockchains. Some of you are maybe even more educated than myself, but if we categorize blockchains, we can categorize them in many ways. One of the way would be like modular and monolithic types. And like the first generation of blockchains or any other technologies are basically will be the monolithic, like Ethereum, Binance Chain, Solana, Bitcoin, and stuff like that. The idea here is that all of the components of the blockchain, like execution layer where the computation happens, where state transition is happening, like, and basically all of the transactions are recorded, smart contract executions are happening in this component of the blockchain. Consensus is basically for networking, for propagation of the information, and security purposes is another component of the blockchains. And data availability is basically the data stored, which is essentially like what kind of data, what is the current state of the data in smart contracts, in accounts, and stuff like that, comes under the data availability layer. And in like first generation of blockchains, like in monolithic blockchains and in new blockchains also some, this approach is adopted. And when we come to, for example, some modular approach, there are rollups can be a part of the like modular blockchains because they leverage the power of like breaking up these components into parts. And for example, we'll process the transactions, the smart contracts, and other stuff on the their own environment, execution environment. It can be like EVM environment or other virtual machine environments that helps to execute some transactions. And the cryptographic proof of these transactions, or the like rolled up version of this transaction can be recorded on some layer 1, which is typically Ethereum right now, but there are also some solutions in other layer 1 chains. And basically the consensus and data availability layer is adapted from one of the, for example, blockchains, which is not necessarily should be monolithic. It can be another blockchain, for example, a Celestia data availability layer or Eigen layer and stuff like that. And execution environments are happening basically on the rollups. Basically, for people who don't know what is rollups, it's essentially you have like bundle of, for example, 1,000 transactions. You roll them up and like submit the like maybe hash or something, they prove that these transactions are happening into layer 1. And this is how you can scale up layer 1s. And modular blockchains are basically currently taking over that space. And this is one of the famous examples, actually, by market cap. This project taken over the Arbitrum, which is the largest layer 2 solution on Ethereum by market cap. This is a project called Celestia. I have a chance to meet with some people from the Celestians. They are doing a good job in like building data availability layer, because if you look into the Ethereum, for example, it does all of that, execution plus data availability, consensus, and plus on top of that there are also some rollups, and it becomes expensive and slow. When we approach, for example, with this road, it can be cheaper because there is no execution, there is no like smart contracts built on Celestia. It is used on the asset data availability layer, and other environments like rollups and applications on top of rollups are built with purpose. Yeah, this kind of approach can be adopted by some of the like companies who are trying to build some blockchain solutions. And if we move to the like generations like of the blockchains, like in V1 we had the Bitcoin, where we can simply transact, and it is transparent, immutable, and all of the core benefits of the blockchains. It has crypto. And V2 is like smart contract capabilities, decentralized applications like Ethereum. In V3, there is an emphasis on scalability, interoperability between other solutions, governance, and V4 is all about like scaling this up, making it more efficient, and making it more for like mass users, mass adoption. And here is this by Martin Halowski guy have created this comparison table that compare like different stack of technologies, and essentially this is like obviously these are the blockchains, but leveraging these technologies that are like in the very end, you may see many other blockchains have been emerged. For example, with Cosmos, there is this BNB chain, Akash, Osmosis, and many other chains have been built. From that, you can see that like third generation blockchains have like higher throughput, has like instant settlements and low prices in general, and a couple of other benefits I will not go through, but it was like part of the reason why we have chosen the Interchain Stack for our technology, because like Interchain Stack uses like Cosmos, SDK, Comet, BFT, and a couple of other technologies in combination. If we talk about philosophy of the like different blockchain solutions, including the one in the picture before, you may notice that there can be like solution with Cosmos where you have basically independent sovereign chains. They can be connected with other chains, and they are independent. They can still like connect with other chains, send messages, send tokens, and stuff like that. But that is the primary philosophy of this ecosystem. For Polkadot and probably for Ethereum, we have like hierarchical approach where essentially you have one layer big chain, which is ultimate source of truth, and other chains like layer 2, layer 3s are built on top of it. And basically this hierarchical approach is adopted by Polkadot, Ethereum, and other stuff. And there is also this avalanche type of topology where you have subnets where essentially one chain secures another, and this is kind of mesh network is emerging. And yeah, it can be also a mixture of all of that. There is like advantages and disadvantages of each, but if we proceed, the last topic I want to cover for the intro of this presentation is rollups. Like building your own chain obviously involves a lot of bootstrapping work in terms of setting up the validators, the nodes, and a couple of other infrastructures. And with like rollups, you can basically have a functioning chain for your own purposes, which leverages one of the like layer 1 solutions. And for example, if we take Celestia, which is data availability layer, which means like if you are building on top of it, it can be relatively cheaper than if you are building on top of Ethereum, for example. There are a couple of rollup frameworks like Rollkit, Dimension, Sovereign, which offers basically like the tools to build the chain on top of Celestia. There is an OP stack which is adopted by tens of couple of dozens, maybe chains on mainnets and testnets. Right now, it's also a popular solution for a rollup to build some modular layer 2 chain. Arbitrum stack is another example. And obviously, they are leveraging also different like virtual machines. There is one called Stacker, which is leveraging moved virtual machine, like Rollkit. With Rollkit, you can build on Celestia using EVM or using Cosmos or using Cosmos SDK. So yeah, there are different solutions, and we were exploring most of them when we were deciding on the blockchain solution for our company. And we came with the Interchain Stack as a basically go-to technology for us because it offers a couple of benefits. Interchain Stack consists of basically several technologies, including Tendermint Core, which is now called as a Comet BFT, which is a consensus engine, Cosmos SDK for building the blockchains and modules, and IBC protocol. It's the protocol which connects blockchains with blockchains, not only in the Cosmos ecosystem, but also beyond. You can connect with Ethereum, you can connect with the Polkadot ecosystem through this particular protocol and exchange messages, tokens, currencies, or other type of data with other blockchain, creating this interoperability between chains, which is also one of the like criteria for next generation of blockchains, right? And this is basically bare bone of like the basic chain, which can be built with several minutes if you know how, and with a couple of more days you can bootstrap some minimal working chain if you already have experience in this. And it consists of the following thing. It is a blockchain node, and this blockchain node contains, for example, the binary of the chain, and which consists of the, for example, Cosmos SDK, Comet BFT. You can adapt some other components, but with this minimum, you will have the actual state machine where you can basically record the data about, for example, where you have the data about balances of the user, for example, the governance, the staking, and many other states. And Comet BFT for like consensus networking and stuff like this. And in combination, it will be a working blockchain like this node. If you put it on the multiple like computers and basically coordinates the genesis, you can launch your own blockchain with this too. And it offers also the modular approach in terms of building the application. Like, for example, currently, like you may see that there are a couple of modules, and these are basically the storages of states, and Cosmos SDK is basically having the storages of states. And with this routing, whenever some messages coming, they will route through and go to one of the modules. For example, if user wants to stake his token, it will go with a staking module, and some actions will be executed and such. There is also another module called Cosmosm, which enables smart contract capabilities in the Cosmos-based blockchains, and basically you can start building your smart contracts on Rust. And here is basically my my pull request, which you can check if you want to apply your. I mean, if you want to add the smart contract capability for your Cosmos blockchain or for your rollup, you can use this as an inspiration. Yeah, and with this you can relatively easily have your Cosmosm module in your chain. Cosmosm in general offers the following thing. It is basically a module for smart contracts, and where you have each smart contract basically have its own internal state, like storage, where you can read and write the data, and every execution, every writing the data on the smart contract costs some gas. And in these particular smart contracts, like Cosmosm-based smart contracts can be considered as an actors, which reacts to certain messages from outside. And the messages from outside can be from users, from like machines, from services, or from other actors like contracts. And these actors modify their own state, and obviously they can also affect other states, all through like the message exchanges. And basically the actor processes all of these messages, like each smart contract processes messages in first in, first out manner, which is unlike in Ethereum, in EVM, I mean. And basically it offers this serialized execution, which prevents reentrancy attack, which is common vector vulnerability. And yeah, basically, if you want to interact, make sure that one contract is interacting with another. You need to know the addresses, and you can also send messages between the smart contracts. Okay, so this was the overview of the Interchain Stack, and let's explore how our company called Enoda is basically leveraging these technologies to build the transactive platform for basically our devices and other third-party devices in the grid. Enoda, basically, this is description from our website. We are delivering the platforms of advanced technologies which help to increase the capacity of the grid for renewable generation. So currently, it's like in the different grids, you can inject maybe like 30% or 35% of the renewables, which is basically at the limit. You cannot go up because otherwise you will have some instability in the system. And with some of the technologies which Enoda is building, including the hardware-based prime exchanger device, which is essentially the next generation of power transformers or substation, we can have the active power flows and literally help with the system stability and basically increasing the grid capacity. So, and this prime exchanger devices is like our primary basically business model. But on top of it, to coordinate these devices and others so that they can perform the optimally, we have another platform which is called Ensemble, which which is basically a layer 1 blockchain with smart contract capabilities for wide range of energy applications, from simple device coordination of all of these prime exchanger devices to aggregated energy market trading and other decentralized applications. So with speaking of which, let's try to go for the demo.
Sorry, it's a bit slow. Signal is not too good, but I will take the phone here.
Okay, yeah. So basically, underneath you may see the blockchain explorer with like blocks coming up, and here is one of the like applications, which is basically for device coordination. These are the prime exchanger devices I was talking earlier about. Essentially, what they can do, they can step up and step down the voltage and do some other operations like harmonic removals and other stuff in order to stabilize the grid. But what is unique selling point of these devices, they can also participate as a basically in the energy, in the balancing energy market as a energy consumer or producer. So that is a uniqueness about these devices, and there are also actually many different uniquenesses. And basically, here is like the places from Edinburgh. If someone noticed, Calton Hill, Lees, Stockbridge, Newtown, and at the start, they are like disconnected, and they have like their own smart contracts. And if they want to register themselves as a part of the, for example, the market, right? As if they want to participate in the market, they should be united in the fleet, because typically you need to have like a minimum capacity basically to actually participate in real balancing markets, which is like different markets like ESO and stuff like that. And for that, they will be connected and the fleet will be created, and now they will be ready to participate, for example, in the energy balancing markets. And imagine that in the balancing market there is a deficit of, for example, 50 kilowatt of energy, right? And basically there comes a signal that we need like 50 kilowatt and after that, for example, these devices individually start to bid and say, for example, I can provide this much power, for example, 25 or 30 kilowatt, 28 kilowatt. And you may also notice, like, it's a bit buggy, but you may also notice that transactions are coming in the blockchain explorer, and you can also like check them, like execute contract transactions. Yeah, and basically after like they have submitted the bids, you would notice that they are this means that they have this available power, and they are ready to participate in the market. And after that, the market clearing is happening. Like for example, if they need only 50 kilowatts. But they obviously, all of the prime exchangers submit like their own like capacities. Then there will be the optimization performed, the coordination performed, and the actual dispatch is happening on the grid. So these devices are actually supplying, for example, 8, 11, 9, and 12, 10 kilowatt energy to the grid. That's how they are like performing like the coordination, come up with the dispatchable power, which can, in the end of the day, help to stabilize the grid and basically cover the required demand with this much supply. Basically, that is it for my speech. Thank you for listening.